Okay, 1.4 projectile motion. So projectile motion, when you throw something to the sky and it land on the ground, is projectile motion. Or you can just throw it in front and it automatically, of course, move to the ground, right? Your initial velocity could be just in X direction, or it could be just in Y direction, or it could be with an angle, right? So it is two-dimensional motion. This projectile motion is two-dimensional. So if we analyzing this two-dimensional motion, we have an X and we have a Y value for this projection motion. Can I ask you, what do you think the motion will be in X direction? So whenever you do the question, you have to divide your problem to the X direction and Y direction. What kind of motion do you think we have in X direction? Do you think this is constant velocity or is constant acceleration? So does any force apply in X direction when your ball in air? Is there any force acting on your ball? No, right? It's just on an air. So in X direction, we have constant velocity. But in Y direction, is there any force acting on your object in Y direction? It's gravity, right? The gravity pull this one down. That's why you have acceleration in Y direction. So this is constant. Acceleration. Got it? So for constant velocity motion, I mean, in X direction, you just have one formula. Velocity in X direction is displacement in X direction. I put it as a delta X, maybe, divided by time. For Y direction, which is the constant acceleration, this formula that we had before, apply for that. Any question?
No.
Okay, let's just do a question so you'll see that better. Look at this. A ball is thrown off a balcony and has initial velocity 18 meters horizontally. This is initial velocity horizontally, true? So Vx is 80 meters per second. What is the velocity initially in vertically? What do you think? It's 0, right? Because the initial velocity has X component, so no Y component. The initial velocity in Y direction is 0. Determine the position of the ball after 1 second, 2, 3, and 4 seconds. So position of the ball, I want to do that. Another things I know is I have a gravitational acceleration here, which is negative 9.8.
Yep.
Right. And I know I want to find the distance after 1 second. So I have time. So you have 3 things. You can find the 4th one using the proper equation. Equation that you need to look for here. This is the proper equation. We have V initial, we have time, we have acceleration. I can use this to find the position of the object after 1 second. So we use that. Here they first find the X position for us, right? So when you have a time and you know velocity in X direction, after 1 second, 1, you have velocity 18. So you can find the X position, which is 18. For y position that I explained, we have time, we have initial velocity, acceleration, use this. This is your y. So then this point, which is 18 meter, 4.9, this is x, and this is your y. You can grab it. This is 18 meter, and this is x and y. This is this point. After 2 seconds, I can do it again. And instead of the time here, you put 2, you find the x component. Instead of the time you put 2, you find y component. Again, this second point, you can find it. Any question?
No.
And so on, then you can graph it as a curve. Now here is a child travels down. Child travels down a water slide, leaving it with a velocity of 4.2 meters per second horizontally at a figure. So it means this is the projectile happening here. It is gonna be into the x direction, right? Means you have Vx is 4.2 and it's gonna be constant velocity in x direction. V initially in y direction gonna be 0. Landing swimming pool 32 meters below the slide means the height here is 3.2, means this is the delta y, the displacement in y direction is 3.2. For how long the child is airborne, you need to find time. What else I know? I know gravitational acceleration is negative 9.8. Yes, make sure the delta y is negative because it's going down, right? So you're using the proper equation to find the time. The proper equation is, again, the same thing that we did use before. Since we have V initial, you want to find time, we have acceleration, you want to find time, we have delta phi. So this is the equation that you use. Let's give you a quadratic, not quadratic because the V0 is 0, right? So here what you use, because Vi is 0, so this term you don't have, you just, this delta y is equal half a delta t power 2. You just need to rearrange it for time. Time going to be square root of both sides. Then you put the delta y is 3.2, 9.8. Both of them is negative, so it turned to positive under square root. And the time is that, but you just accept the positive value because the time cannot get negative, right? Then part B said, determine the child's horizontal displacement while in air. Since we have time, you know, the only equation I have for x direction, of course, is V is equal to displacement over time. Now, since I got a time from previous step, and I have velocity, I can find a displacement, true? Determine the child's velocity upon entering the water. So it means I need to find final velocity in y direction. So I can choose any equation for that. I can choose V final power 2 minus V initial power 2 equal to 2a delta y. I have delta y, I have acceleration, I have initial velocity, which is 0. I can find final velocity. But here the final velocity in y direction. Final velocity in x direction is still going to be 4.2 because in x direction you have constant velocity motion, right? So you have two components. After you find final velocity in y direction, you have to put them together. Using the Pythagorean theorem, the x component remained the same. The final x component is still going to be 4.2, like initial. Final velocity, you find it from the formula. Then using the Pythagorean theorem, then you need to find the angle as well, right? Tan inverse of y component over x component. Then you find the angle. Any question?
No. Yeah.
I'm gonna erase that. So for this one, again, we have a helicopter traveling horizontally 82 meters above the ground. So we have a delta Y. The pilot prepares to release a package, land on the ground 96 meters horizontal. So this is the delta X. The pilot doesn't throw the package, but it lets drop. What is initial velocity of the package relative to the ground? So since the helicopter is moving in X direction, when we drop it, basically the package and the helicopter, they're moving with the same velocity. It means you have initial velocity in X direction, true? So you know your delta X is 96 meters. You want to find the time, initial velocity in X direction. In Y direction, you know, initial velocity going to be 0 because it's just no initial velocity in Y direction. Delta Y is 82, A is 9.8. So we have 3 things in Y direction. You can find a 4th one using the proper formula. This formula, V initial is 0. That's why just delta Y is equal to 182. Again, you just need to rearrange for time. You rearrange it for time, you put the values, you find the time, then you, in X direction, right? You want to find how, initial velocity in X direction. Then you find that, you know, this is the only equation that you have for X direction. Delta X is given to you. Time you found it from previous step. You just calculate the initial velocity in X direction, the initial velocity of the package or the speed of the helicopter. Any question?
No, thank you.
So question number 3, 4, and 5. This is page 3, 4, 5. This is page 46.
3, 4, 5 is 46.
Yes. Now here is analyzing more complex projectile motion. When your initial velocity is with an angle. So then you have an X component and you have a Y component, right? Let's just look at this question. The initial velocity is 42.32 above the horizontal. First things you do, you find the X and Y component of your velocity, because in X direction you have a constant velocity motion, and in Y direction you have a constant acceleration motion. So you know the geometry. The opposite gonna be sine. So Y value gonna be V initial sine theta, and X component gonna be adjacent, gonna be cosine. We have done this before. We're finding the component of the X vector in X and X direction and Y direction. You know what's going on. Then we just do the question. See, horizontal range. You need to find a horizontal range. So horizontal range means the time, means the distance in X direction. So if this is your projectile motion, right? From here to here is the range, delta X. To do that, you need to find the time, right? Because in X direction, you have velocity is equal to delta X over time. If you know the velocity in X direction, you need to know the time to find the range. You need to find the time from the Y motion. Can you tell me what is the delta Y from a starting point and to when it hit the ground?
Delta Y is 0.
0, very good, because it started at the same position and same, so 0 minus 0, right? It's 0. Perfect. So we have that. We know the acceleration is negative 9.8.
Yes.
And I know the initial velocity in Y direction, right? What is it? It's 22. So I can't find the time. I have 3 things. I can find the fourth one using the proper equation. So you know what equation we use? This is the equation. V initial delta t. The delta y is 0, V initial is 22, A is negative 4.9. You're looking for time. This is a quadratic formula, or you can just factor the delta t and then you equal this bracket to 0 and to find the delta t. And the delta t is given, you equal it to 0, you find that 4.5. Now I can use that here. V in x direction, I got it from the previous statistics 36, multiplied by the time. It just we got from y direction. Just give you the range. Any question?
No.
Then we want to find the final velocity. Easy. The maximum, okay, determine the maximum height. Okay, make sure. The next question is determine the maximum height, means from here to here, right? When you reach the maximum height in y direction, Vy, you're gonna be 0 because it's a stop for a moment and come back, right? So V final will be 0 in y direction at highest point. V initially, we know from the previous acceleration, we know is negative 9.8. And we just rearrange it for delta y because we want to find what is the highest point it's moved, right? I want to find this. Any question?
No.
Now we want to find the horizontal displacement when delta y is 50. So delta y is 50 means I have that. Initial velocity in y direction I have. I want to find time, acceleration we have. Just you have this. I did explain you how to use a quadratic formula before to solve for time.
Yeah.
You're good?
Yeah, yes.
Okay. That's the question. So question number 9 and 10. This is page 50, 50.
Yes, sir.
Okay, I think that was the last thing. Yes.